2x. So I like to give that sign to the term, and then you multiply by all three. We talked about lining these up vertically when they're in the same exponent category. So negative 2x times negative x, probably already said that's 2x squared minus 8x. And then we've got some terms that do combine here. So 4x cubed minus 2x cubed is 2x cubed plus 2x squared minus 8x.
Yes.
Right. So my guess is you'll get some sort of multiply or divide polynomial thing like that. Now, we did 5. We can certainly do some more polynomial division, but let's move to 6 and 7. 7's probably the question you would see on a test, but the thing you want to avoid here is you've been doing so many multiplication division problems that you don't somehow, miss the fact that there's a plus operator there. Some students need to, like, you get, if you do more than 2 problems in a row of one type, sometimes you don't realize the next is actually very different. So here you're trying to decide why you need the parentheses, and you don't need them. You don't need them at all. They're only needed when there's a minus sign or a number out in front. So in this case, you drop the parentheses, and from here you decide, okay, can I combine any like terms? Is there anything that's the same? Looks like that minus 2x and minus x you can combine. So you get x cubed plus x squared. So it's generally preferred to put it in descending order, minus 3x plus 4.
And that's it.
That's it. And you might think there's more to do, but that's because we're used to multiplying or dividing. Here you're just adding. This is prerequisite, something you saw in a previous class, most likely.
Yeah.
Now 7's got a tiny bit more work, because there's a negative sign, and that there is a reason that the parentheses are here, because this negative has to be distributed to each one of these. I've been moving more towards this change of the signs of everything inside. So it becomes minus x squared plus x minus 4. I notice I do that first before I deal with anything on the left, because the left you're just bringing straight down. Okay, and then again, just combining like terms, like the 3x squared goes with the minus x squared. So that becomes 2x squared. And I think I mentioned this before. Some students like to cancel them out as they go. Minus 2x and positive x, you can double underline if you like that. Becomes minus x. And then you bring down the last term there.
Yeah.
All right, so I know we did 8, but just as a reminder, if you've got that in front of you, do you have this in front of you, or are you looking at it electronically?
I'm looking at it electronically.
Okay, let me just make kind of a problem like 8. Let's go like 4x minus 3 squared. It's always best to write this out as 2 binomials multiplied by each other.
Yeah. And then you just FOIL, right?
You just FOIL here. Do you want to try FOILing this one just to kind of get in the action here? Yeah. And then I'll look ahead here to our future problems, see what we got.
I got 16x squared minus 24x minus 9.
Look at the sign of that last term.
Plus 9, yeah.
Yeah, and I remember you doing that last time. So, we're just prone to making the same mistakes. I hate even calling it a mistake, but just the same thing over and over again. You know yourself, so you should be on the lookout for that when you're doing this.
Yeah.
Okay, so I'm going to move to 11 and 12. For 11 and 12, I don't see the instructions, but my guess is it's some sort of like determine if the value of x is a 0 of the polynomial. Something like that, possibly. Yeah. And if it doesn't specify, I don't know if you have a way to see this, but if it does not specify, we're going to use synthetic division. That's probably, I would say with a lot of likely probability that's the case here. So the minus 2 goes in the box. And then you have to bring down each of the coefficients of the cubic, the squared, and the x, and then the constant term, which there is none. What is the coefficient in front of x cubed?
1.
1, yeah, 1. And then what's the next coefficient in front of x squared?
-3.
3, -10. And then very important is there's actually a 0 there at the end. Excuse me. So do you remember how to do synthetic division, or do you want to see an example? I was going to ask you to try this or.
Yes, I do remember how to do this.
Okay, why don't you try this one? Let me know what you come up with. Then we'll look at it together.
Okay. Okay. I got 1, -5, 0, 0.
Okay, let me just check that. I agree with that. -2 there. I agree with that. 10. Yep, perfect. Okay, so that means that yes, -2 is a root. Okay, and do you see the instructions, or do you have them? Because that's about as far as I would go with this problem.
Yeah, it's just like talking about the zeros and then like the factors. Let me just find it again.
Okay. So let's talk about number 12 here. Let me get it snipped in because it's got kind of a little wrinkle thing that makes it just a tiny bit different than the one we just did. 12 is probably the one you'd see on your test anyway. So, all right. Okay, so a couple of things here. It does not give you the x value, okay? You have to set this equal to 0 and solve for x. And just to be clear, I'm referring to the x -3 = 0.
Yeah.
Okay, so the 3 is what goes in the box. It's very easy to put the wrong number in the box. I would just ask that you really pay attention to that. Another important thing here is that it's missing. It goes from power of 4 to power of 2. It's missing 0x³ and 0x. Very, very important to remember those. You might also see that in the long division problem, polynomial long division problem that you get on this test or quiz. So really just pay attention to that one, and just be aware that could be the case. So that affects the numbers that go in this row here with the synthetic division. Okay.
Yeah.
So go ahead and give this one a try, please, and let me know what you come up with.
I got 1, 3, 7, 21, and then 0.
Okay, let me just check that. Looks good. Looks good. Good. Yeah, perfect. Okay, so that means that 3 is a root. Okay. Now you did this perfectly. I've tried to show you the possible little things. So if you don't put the zeros in, you don't get that it's a root. So you got to just really be on top of that.
Yeah.
But that's great. I'm glad you're able to do that. Okay, so let's looking ahead here. I don't think we did 13, but I'm not sure. You have any way to check?
Yeah, I don't think we did do 13.
Okay.
I don't remember doing that one.
Yeah, so let's look at it together. Now you're going to have a calculator on this test? Okay. All right. Now, how comfortable are you using your calculator to graph this at this point?
I'm pretty comfortable.
Okay. So let me have you do this. Do you have your calculator handy?
Yes, I do.
Okay, I'd like you to graph it and see if you have any questions about how to calculate the zeros from the graph. And I'll do it as well, just so you can follow along in case there's a question. Let me get that out. My calculator here. I can't recall if we've done this before. I'm going to share my calculator screen, and it's a TI-83. If you have got an 84, I mean it's close enough.
Yeah.
But let me just always double check that you've graphed it correctly. It's the right function, all that stuff. All right, I'm going to graph it. See what we see. So let me know when you graph it if you get something similar.
Yeah, mine just like deleted, so I have to start over.
Oh, okay.
Okay, I think I got what your graph looks like.
Let's go back to the y equals and just make sure we've got the same thing graphed. It's x to the 5th minus 4x to the 4th plus 2x cubed minus 26x squared minus 63x plus 90.
Yeah.
Okay, now when you go to graph, and this is where it looks like there's a 0 at -2, +1, and then +5.
Mhm.
Okay. Now, do you have any idea how to confirm that? If you don't, that's okay. I want to show you, but that's the whole point here.
No.
Okay, so there's a couple of ways. I think probably the easiest way is to go to second table.
Oh,
Okay.
right. Yeah. We did
And to
that.
just look at those values. Like at -2 is y 0. It's got to be exactly 0. Now, if it says like 1e to the -16, that is also a 0. Looks like 1 is a 0, and then like I mentioned, looks like 5 is a 0. Now, a couple of things here that might be important. Sometimes you get a root like 3 and 3.5. Okay, and this table is not set up for that, so we would have to make some changes to the table. So to do that, the best way is to go second table set, and if you're not comfortable changing the table, you can switch from auto to ask. Okay, now by doing that, when you go back to the table, all those values that we just had are gone. So you'd have to manually enter like -2 and get 0, 1 and get 0, 5 and get 0. But where it works nicely is, let's say you think there's one at 3.5, you can potentially see that here. But you change that in second table set, it's under window, and you're changing the independent, which is X, from auto to ask. Generally, you want to keep it on auto.
Mhm.
Okay, so very important that you're able to do that. Let me go back to the other screen here. Make sure you write down your zeros, and we're just going to use synthetic division here to see if it works. So I'll start with I don't know, start with -2. It doesn't really matter because they all should work. kind of amazing that this works. I mean, it really,
Yeah, it is.
it's it's like a Halloween thing, mystical. All right, 1 minus 2 minus 6. Okay. Let's see here, 108. And then 45 minus 90. And one of the nice things is when you know it works, you're kind of looking towards the destination. You know what to kind of look for, so that rather than rewriting this line, I just keep going. I'll just put 1 right in the box and just keep going here. 1 minus 5 minus 5 9 9 minus 45 minus 45 and 0. We keep wanting that 0 there. And then you try 5. The order that you try them in does not matter. So 1 5 0 0 9 45 0. Okay, fantastic. So we're all done, except we're not all done.
Yeah.
Okay, because it's a 5th degree polynomial. So that means there are 5 zeros. And how many did we find?
3.
3 of them. So help me out here. What's left over here? If we were to write this as a x to a power and a number, can you tell me how to do that from this? Or if you need a reminder, I can help.
It would be, so we started off with x to the 5th, so then it would be x cubed.
So x to the 5th is up here. And then it became
x squared.
X to the 4th. Yeah. So you should always be able to get it down to an x squared plus 0x plus 9. So it effectively becomes x squared plus 9.
Yeah. So isn't that just one of the zeros?
This one does not have any real zeros. This one's got imaginary zeros.
Okay.
Okay. Now as a reminder here, the solutions were -2, 1, and 5. If you want to write these in factored form now, this is in factored form. How do you write one of these in factored form?
It'd be parentheses x plus 5.
So that would correspond to -5.
Oh, because you said it equal to x, right?
Yes. Yeah.
Okay.
So you like what you just said, it would be x equals 5, which is true. But you have to move that 5 over by subtracting.
Yeah. So it'd be x minus 5.
Okay, that's good. Give me how about for 1? What would that be?
X minus 1.
And for -2?
X plus 2.
Perfect. Okay, so you're really doing great here. Now this last one, do you remember how to solve this for the imaginary zeros?
You subtract 9 to both
Yes.
sides, and then you take the square root.
Okay, I like it so far. Plus or minus the square root of -9. Can you work through that a little bit more?
So it would be x equals plus or minus 3i.
Yeah, perfect. So that like what I've boxed in, that's factored form.
Yeah.
Okay, but if it asks for the zeros or the roots or the solutions are -2, 1, 5, 3i minus 3i.
Yeah.
Any questions on that?
No.
All right.
I think, can we do the like long division ones where you have to take like x minus 2 and then put it in for that whole equation?
We can do a couple of long division ones. Yeah. Is it okay if we do 14 first? Because it kind of
Yeah.
falls into the same category.
Yeah.
Okay. All right. So I want you to graph 14 and tell me the 2 roots. There's 4, but only 2 of them you'll be able to see. So I want to grab your calculator if you have questions about how to find them.
Do you know, so I have a TI 84 and I just like plugged it in, and then when I press graph, it says like hit second or like quit or something like that. And it's like not giving me the graph.
So you may have put it, you want to hit the go to button on that instead of the quit. And because what the go to will do, it'll try to take you to where it thinks there's a problem. A lot of times you put a minus and then a subtraction, or you put you use a minus instead of a subtraction on your calculator.
Okay. Wait, so I hit what?
You want to use the subtraction, but some students hit the minus button instead. Let me try to show you this here. See if we can get this together. So are you seeing the calculator screen?
Yes.
Okay. So if I go to y equals, I got to turn it on first. Y equals clear, and I go x to the fourth, but I use this subtraction 81, and I go to graph, it's going to complain. Okay, maybe you saw that's error syntax. Now, instead of hitting quit, this is like it's trying to help you. If you hit the go to button, it's trying to help you, and you hit enter, it's going to take you to where it says, there's a problem right there. And that might help you say, oh yeah, I put a minus instead of an 81.
On mine right now, it only says quit. Like it doesn't even have the go to.
Okay. The only thing I could really suggest here, which is really not the best, is to go to like second mem and do a reset and then just start over. But if you got programs, you got something else in there, that would be my only way I could help here. That would be one option. Without seeing it, it's under mem, under the plus. If you hit second mem, if you go down to 7, it'll reset. I think it'll say reset all or something, and you say yes.
Okay.
But I'd like you to graph this equation. Tell me the two roots that you see.
Okay, now it's working. And then go to second table.
You could look at you look at the graph first just to kind of get an idea of where you think it is. Would be a good way to just or you can go right to the table and maybe you can see the numbers, but you may not see them all. You may only show you the positives, or you may need both positive and negative.
The graphs are both on like -3 and 3.
Yeah, so go to the table and just confirm that for me.
Yeah, so the 0 is going to be on 3.
Yes. What about -3? You can hit the up arrow to go backwards. Yeah. Okay. So now these work, and that's great because we want to reduce this thing using synthetic division. Now I've got a 1 for x to the fourth. What is missing between x to the fourth and 81?
The x cubed and x squared.
And an x.
And an x, yeah.
So I used to have to write this because I would just not want to miss any of these, but it's up to you if you do that. You just want to make sure you get them all. Because you might think, well, why does it matter? Well, if you miss one, it doesn't cancel out at the end. It's 1. So you get 3, 3, 9, 9, 27, 27. You miss one of the zeros, you get a 27 at the end instead of 81. Okay. And then you try that other one, the other one you found. So 1 minus 3 gives you 0, 0, 9 minus 27, 0. Okay. So just like I asked in the previous problem, 3 and -3 are the roots. These are the roots. Roots, zeros, solutions, they all mean the same thing. But if you wanted to write it in factored form, can you tell me what 3 and -3 are in factored form?
It'd be x -3 and x plus 3.
Yes. Very good. Now, look at what's left over here. And keep in mind, you started with an x to the fourth. What's left over here? This 1, 0, and 9.
It would be x to x squared.
X squared. So it was x to the fourth, then it became x cubed. Now it's x squared plus 9, like that.
Yeah.
Okay.
Then isn't that where you take the square root of 9?
Yes. So what are the other two solutions that are not real? We did this in the previous problem. If you need me to scroll up, I can.
Yeah, can you scroll up real quick?
Yes. Yes. Okay. So x squared plus 9, set it equal to 0. Subtract square root.
Oh yeah, yeah. It's positive. So it'll be positive 3i and then negative 3i.
Right. So this is your factored form. And the reason we're doing this is we don't know what it'll say. Like it might say in the instructions, write your answer in factored form, write your solutions. Like you have to be able to do any form that they ask.
Yeah.
Is that okay?
Yes.
That's clear. All right. Fantastic. All right. So you want to do some long division, polynomial long division.
Yes.
And I think that's great. I have to look for some problems. Just give me 30 seconds to a minute here. You can take a break if you need, but let's
Okay.
let me look for these. Okay, let's start out with like kind of a more of a basic one, and then we'll move to some harder ones here. Okay, something like this: x squared minus x minus 7x minus 11 divided by x minus 8. So I'm taking you back maybe even 10 years when you were in third, fourth, fifth grade, somewhere in there, and you put something outside the house and you put something inside the house. And the first thing always goes inside the house, and then the second thing goes outside. And your focus is on the x squared and then the x. And you ask yourself, what do I multiply x by to get x squared?
Yeah.
The answer is just x. Now notice I put that in the x column, not the x squared column, the x column. So now
Yeah.
you take this x and you multiply by both of these.
Okay.
So you get x squared minus 8x. And this is Matthew's preference. I like to change the signs.
Yeah.
Okay, so this one becomes negative, this one becomes positive. Why do I do that? Because I like to add rather than subtract. And then we work vertically. So x squared minus x squared 0. It should always, 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 always be the case that you get 0 here. If you don't, you did something wrong. You may get 0 in the next one, but that's dependent on many other things. So minus 7x plus 8x gives you x. And then if you remember from your days of long division, you always bring down at least one term or thing. Sometimes it's a number. So then your focus is it's again on this here. It's like, what do you multiply x by on the left here? The one on the outside. Sorry, you can't see that. Now you can see it. This x over here. What do you multiply this x by to get it this x here? The answer is 1.
Yeah.
And then you take 1 and you multiply it by each of these.
Yeah.
So you get x minus 8.
And then you flip the signs.
Flip
Right?
the signs. Yep, if you like that, that's fine. Flip the signs. Subtract plus. And then you get your a number down here. Now, do you always get a number? No. Sometimes you get 0. But this number is your remainder. This thing up here is called your quotient. And then your thing on the left here is called your divisor. I don't make these up. I generally just go R, Q, and D. And then the way you write your answer is always Q plus R over D. There's actually another way to do it, but we'll go with that.
Yeah.
But the key is you gotta get this thing right. You gotta get the remainder right.
So it would be x plus 1 and then plus -3 over x minus 8.
That's exactly right.
Okay.
All right, so I'm going to give you one to try here on your own. May seem like a lot of work, but you've done this before, so it's totally doable. Let me not give you that. Give me a different slide. I'll give you this one. X squared plus 10x plus 18 divided by x plus 5. All right, so give that a try, please. See what you come up with.
So after you get like 5x plus 18, you bring the 18 down.
Yes, you want to bring the 18 down.
And then after that, so like the last one, you got x plus 1 as your quotient. Is
Yep.
it going to be x plus 5?
Is as the quotient? Yes,
Okay.
that's correct. And let me know what you get for a remainder.
Okay, I got -7.
Yes. So how would you write your final answer?
So it would be x plus 5 plus -7 over x plus 5.
Yes. Yes. Very good.
Okay,
Okay.
that makes way much more sense now.
All right. So we're gonna do another one here. We got to just do a couple of the ones that you might see on a test. Because that's the whole point here. We're practicing for the test. I think you're gonna get third degree polynomial or more. I also think you're gonna get the following as well. So let me show you this one. So it's x cubed minus 30x. No, I'm sorry. I guess, okay. This could happen. I might as well show this to you. It kind of depends on your instructor, what they do. So do you notice on the left here that it's out of order? It's not in descending order.
Yes.
It needs to be. It absolutely has to be. So you do have to write it in descending order. That's different than having, say, a missing term, but something like this. It's no different than the previous ones, just a little more work. Okay. Do you want to try carrying this one out from here?
Yeah.
And then we'll get back to the other assignment we've been working on.
Okay. So it's how many times x goes into x cubed now?
Yes. Yes. You always look at the two leading things.
Yeah. Okay, I got, oh wait. Hold on. I got 9 as the remainder.
Okay. What did you get in your second term here in your
Oh,
quotient?
I got x squared minus 7x minus 9.
Okay, looking good so far. Let me keep going here. Yep, looking even better. You said -9.
Yeah,
Yeah, that's perfect. And your remainder is 9.
yes.
Perfect. Yeah, it's perfect. So you got it. The only other type of problem that you might see would be something where it's missing like the 4x squared and you have to put in a 0x squared in here.
Yeah,
I mean, that's it. But it's the same process that you carry out. So those are the only kind of two like little wrinkles that you might see.
yeah.
But, any questions on our care? Can we move on? Do you want one more long division problem or should we
Maybe
move?
one more just to keep it.
Okay. Okay. So I'll just make one up here. Like I said, let's say it's like x cubed minus 5x plus 3 divided by x minus 1. So this is one of those in question where you have to put that 0x squared in.
Yeah.
You must. There is no partial credit if you do that, because it's just completely wrong.
Okay. I think I did this wrong. Ugh.
Where did you get x squared in the first position up here?
Yes.
And did you get 1x squared minus 5x?
Yeah.
Okay. So you're trying to get to x squared. So what goes here? What do you
1x.
multiply? Yeah, 1x, so plus x. So that's x squared minus x, and then you change the signs.
Yeah, that's where I go.
Flip the signs, something like that. So go ahead and keep working it out from here.
Okay, I got -1 as my remainder.
Okay, what's the last? What did you get up here for your last?
-4.
Perfect. Yeah. Yeah, and then you change the signs, so you get -1 as your remainder. Perfect. So that since I can't see your paper, I don't know what you did or why you felt like you went wrong. Unfortunately, you kind of have to restart completely when you're not sure.
Yeah.
And
I
I hate
Mine
saying that, but
looks
that's
kind like exactly like yours. I think I just got confused on like the top part x squared plus 1x minus 4, like which numbers to multiply x to get those numbers. I just got confused for a second.
do you normally get extra time on your test, or do you normally have some time left over before you submit it?
Um, we just have like all class periods and we just have like 50 minutes to do our test.
Okay, this would be the type of problem that I would just redo completely. Like, even if you think you got it right, like cover it up, get a piece of paper, or do it on the back of another piece of paper, and just like completely redo it without looking at it, just to see if it's the same.
Yeah.
Because it's so easy. Like, you just, is it minus or plus? Did I change the sign? Did I not? Because it's not hard. I mean, you're just multiplying things together and adding and subtracting. But if you haven't done it in a while, you just keep that in mind.
Yeah.
Okay, let's move to 17 and 18. So a couple of things here. If you wanted to reflect over the x-axis, which is exactly what 17 asks for, it is the following. It is f of x becomes minus on the outside f of x. And think of it this way. It's like x squared going to minus x squared. It goes from opening up to opening down. That's one easy way to remember that. All right. So now, in terms of like, well, what do you do? What does Isabel do here in question 17? Well, minus f of x means to minus everything that's on the right-hand side. So you're going to distribute in everything, change the signs of everything. Except I didn't do that. Minus 3x cubed plus 2x squared plus 4x minus 1.
Yeah.
Okay, now the next thing it says here, maybe let me snip that in. Maybe you're not seeing that. For 17 is it says to do the reflection over the x-axis. We did that, followed by, and that's very important, you have to do things in order, followed by 2 units up. So 2 units up means take your f of x and go up by 2. So you're going to effectively add 2 plus 2 to it. So you take the thing that you just did, that you just found, and you're going to literally just add 2 to it.
Yeah.
Okay, so then it becomes minus x to the 4th minus 3x cubed plus 2x squared. A lot of writing here, plus 1. Well, 18 actually has a little bit more of a challenge to it. I guess we'll look at that next. Any questions on 17?
No.
Okay, so for 18, let me get that question. All right, so for 18, come on. For 18, it says reflection in the y-axis. So that one's kind of like, what do you mean by y-axis? Well, it's this one right here. So it's like if it's I don't know, if it looks like that, it goes like that. That's not a great example, but that's what it is. So in terms of like how to do that, though, it's f of minus x. F of minus x is a y-axis. So in terms of what you do, you put minus x in for x. But you got to be very careful. You have to do it in parentheses.
Yeah.
Maybe what does he mean by that? It means like put it in parentheses like that, so that you're actually applying the power to everything, but it's just the x. So like the 3 is on the outside, but minus x is in parentheses. Okay, and as a reminder here, minus x to an even exponent is always x, minus x to an odd exponent is always minus x. So the first one becomes x to the fourth. With the exponent. So I'm just on the right here, I'm just dealing with the sign, because the next one becomes minus 3x cubed, because the minus effectively comes out.
Yeah.
So for the next one, it would be minus x squared becomes just positive x squared. That's what I mean by this. It stays positive on the right here. So that minus out in front though stays like that. Another way you could look at it is when it's odd, it changes the sign, but when it's even, it doesn't.
Yeah.
Any questions on that? And we can, I think we've got another lesson in it, so we can definitely go through it again. The shift right one unit is kind of I'm surprised that your instructor is asking you to do this, but so it's worth us taking a look at. So if you go back to a parabola, if you want to shift it right, it's actually x minus 1 squared.
Yeah.
Okay, and you got to remember, was it minus, plus, minus, plus? If you got a calculator, you could plug in something in your calculator. You could graph x squared and x minus 1 squared and see if it actually moves it right. So in terms of what you do, every x goes to x minus 1. So this becomes x minus 1 to the fourth, x minus 1 cubed, x minus 1 squared, x minus 1 plus 1, like that.
Yeah.
And that is it. You may want to ask your instructor, but it would be kind of absurd to have you simplify this. This is just a lot to do. It's like a Pascal's triangle problem, a bunch of them.
Yeah.
But you can save that for him or her. All right, well, that does take us to the end of our lesson for tonight. We've got another lesson upcoming. We'll definitely be able to get through everything else here, but have your questions ready. And I'll see you then. I hope you have a great rest of your night. Happy Halloween.
Thank you. Happy Halloween to you too.
All right, bye now.
Bye.